Hello, it is Dr. Liu. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using kits from Science Interactive. In today's video, I'm going to go over the second part of the chemical reactions lab, which deals with double displacement reactions, as well as some others. Today we are looking at chemical reactions. Before I get into the procedure and more details about double displacement reactions, I want to review indications of a chemical reaction. I'm going to make a list of some things to look for when dealing with chemical reactions to show that there is a chemical reaction occurring. So, first, if we see a color change, usually we will have a chemical reaction. Second, we see a formation of a solid. The solid, otherwise known as a precipitate. How does a precipitate look? It's going to look cloudy. If we let a chemical reaction that has formed a precipitate sit for long enough, the precipitant will settle out to the bottom and we will see a distinct solid, similar to how sand settles at the bottom of water. Other two indications of a chemical reaction may be gas evolution in the form of bubbles, or we could have a change in temperature. So for the change in temperature, because we are carrying out the reactions on a small scale, it may be harder to actually observe the change in temperature. Many times you can put the well plate on the back of your hand and you can feel a particular well either warmer or cooler than the room temperature. What I want to point out is for these top set of conditions, I'm going to write right above, these are permanent. Meaning, whenever mixing two chemicals, we may see a slight perturbation or disturbance, but after everything settles and reacts, we will see a permanent color change or a solid that is permanently there. Yes, maybe we see a little bit of cloudiness during mixing, not indication of a chemical reaction. Let's move on and discuss double displacement reactions quickly. So double displacement reactions take on the form where we have a solution, AB, we mix it with another solution. For the purpose of this exercise, one of the products will be a solid and the other product will remain as a solution. So what we are really looking for here is the formation of solid. So this formation of a solid is going to be indicative that we had this double displacement reaction. Remember, in the previous exercise, one of the reactants was a metal element, and it reacted with a solution. Here we have two solutions that are going to be reacting. Let me go through the setup again. So just like the first part of the experiment, you will either have chemicals provided in pipettes, or you will be provided pipettes and the chemicals will be in small vials. There are two chemicals that I want to point out. First one is IKI. The IKI indicator contains iodine. It is packaged separately from the chemical reaction bag in bubble wrap, and it is in a brown bottle. It is light sensitive, so it must be packaged separately. Next, I want to point out the silver nitrate. So the silver nitrate is going to be right here in a small white bottle. If your chemicals did come in pipettes, the silver nitrate is not going to be in a pipette, but rather a small white bottle. Next, when carrying out the reactions in the well plate, the rows of the well plate are labeled with letters A, B, C, will go on to D, so on and so forth. The columns are labeled with numbers. This first well would be considered well, let's see, A1. So I'll move this down just a little. So here would be A1. And then right next to it we would have a, 2, so on and so forth. So when referring in the questions to various reactions, refer to the reaction by the well number to make it easier. So as we wrap up this video, I would like to go over how to answer the questions so that everybody can get maximum points possible. So question number 3 is going to ask you to write chemical reactions for the reactions that form a precipitate. So for example, if we saw a precipitant in A2, I might write A2. So that is the reaction where we have a precipitant. Now I'd write the balanced chemical equation. So let's say we take NaCO3, sodium carbonate, aqueous, plus, let's see, calcium chloride, aqueous. What are we going to form? We're going to form calcium carbonate, which is a solid, plus we're going to form sodium chloride, which is aqueous. So now we have the complete chemical reaction. What is left is to balance, and oh, I forgot the 2 on the carbonate. So I'm not going to go through all of the details to balance, but in order for this reaction to balance, we need to put a 2 right in front of the sodium chloride. So also pay attention to the, what do I have here? States. The states of matter are very important when writing a chemical reaction. They tell us what products to expect and what are the appropriate states of the reactants in order to have the chemical reaction. Let's move on. Okay, next. In the next question, they're going to ask us about precipitation. So, for example, if in A2 again, we see a precipitant, we'd write A2 and we'd say milky white solid. Make sense? What you must do is you must list all reactions with precipitate. Moving on, question number 5. Is going to ask us about color change. So if, let's say, in well A5 we see a color change, I would list A5, and I could write clear to pink as the color change. And again, must list all reactions with color change. Hopefully, I have made the procedure a little bit clearer, made everything a little bit more simpler, so that you all can earn the maximum potential points on the experiment.